So today we're going to continue our study of properties by talking about the distributive property. If you need to look anything up, it'll be chapter 6, lesson 6 in your book. So distributive property gets its own day, actually probably 2 or 3 days, because it is used so often in algebra, and that's where we're headed. Now, I'm going to start with the letters and the variables, and then we'll move to some mental math things, just because I think it's easier to see it when you see with the letters. So what does it mean when we say distribute? If the teacher hands you a pack of papers and said, please distribute these to the class, or if there's been a natural disaster and an organization is trying to distribute water to families who, have been displaced from their homes, what does it mean? Only the people that we like get it? Only the classmates that sit near you get the papers? No, you're going to give it out fairly. Everybody's going to get the same amount. They're going to get an equal share of whatever it is. It's the same thing with distributive property. We're going to give out a number fairly to everything that it's being multiplied by. All right, let's look at an example. And these are multiplication examples. So let's say that we've got 3 times the quantity, 5x plus 2. And that's exactly how I would read it. The parentheses, we would say the quantity. So this is 3 times everything inside. There happens to be 2 pieces or chunks to this problem. So I'm going to do 3 times 5x, and I'm going to use the star so it's not confused. Keep the plus, and I'm going to make it obnoxious so that we can see the difference. And then I'm going to do 3 times 2. Now, I rarely write this all out, but I wanted you to see what we're actually doing. So 3 times 5x is 15x, 3 times 5 times x. Keep the plus, and then 3 times 2 is 6. This is my final answer. I cannot put them together because one has the x and one does not. I know that hurt your brain. It's okay. Leave it like that for your final answer. I don't know what x is, and that's perfectly okay. Let's try another one. This one has a subtraction sign, but outside is still multiplication. 7 times the quantity, 2m minus 5. So we'll give the 7 here, and then keep the sign in the middle. So 7 times 2 is 14 times m, 14m. Keep the subtraction sign, and 7 times 5 is 35. That's it. That's my answer. Now, what happens when there's no number or no coefficient in front of the j, or the variable? There's a 1 there. It's just one of them. Up here we had 2, up here we had 5. This, just one of them. I'm still going to distribute 4 times 1j and 4 times 8. So I get 4j, keep the plus, and 4 times 8 is 32. That's it. That's my answer. Now, you might have a situation where you've got more than 2 pieces. Let's say that we've got 10 times 3x plus 4y plus 5k. Can you tell I totally made those numbers up off the top of my head? I did. That 10 is going to get multiplied by each piece inside. Our original problems only had 2 pieces, so we multiplied twice. Here we've got 3 pieces, so we're going to multiply 3 times. I like to think of the parentheses as kind of like the classroom walls, and each of the things inside are the students. So this class had 2 students. This class had 3 students. Each one of them is going to have to get 10, crayons maybe, or whatever it is, right? So 10 times 3x, keep the plus, 10 times 4j, keep the plus, and 10 times 5k. That's it. Can't put them together. That's as much as we're going to do. If you would like to draw the arcs, I find them very helpful even as an adult. I think they would be helpful for you, especially in the beginning, because it really makes you focus on getting every one of them inside the parentheses. So that's how we're going to use this in algebra. with variables. Let's talk about how we can use this for mental math. And you might already do some tricks like this. We can use this to rewrite and stick strictly with numbers, no letters. So this says 6 times 88. I can't do 88 times 6 in my head. I can rewrite this though. I know that 88 is really 80 plus 8, right? 80 plus 8 is 88. Well, now it looks like a distributive property problem. Let's multiply. 6 times 8 is 48. And this one had an extra 0. So 6 times 80 is 480. Keep the plus. 6 times 8 is 48. I'm much more able to add these in my head than I was to multiply 6 times 88. Yikes. So this is going to go 80 plus 40 is 120. So this is going to go up to 528. Okay. You can also do it with subtraction. So this I could rewrite as 90 plus 9. Totally fine, will get me the right answer. But I want you to think of it in a different way. Isn't 99 really just 100 minus 1? And look, there's a bunch of zeros. Oh, that makes me, and ones, multiplication with ones makes me so happy because it's easy. Okay, so 4 times 100 is 400. Keep the minus. 4 times 1 is 4. What's 400 minus 4? Even if you got to bust out your fingers and count backwards, 396. So you can also use distributive property to do some mental math. There's one other thing that we're going to do with distributive property, but I'm going to hold off on that until tomorrow. I really want to master the giving out part of it today before we start talking about the collective.